And the answer for this, for practically, is to do something digital. We're in that 21st century era where almost all money is digital. Almost everybody here, the majority of your money is numbers on a disk somewhere in the bank. It's not in cash, it's not in gold bars buried in a safe underground. It's stuff that's it's bytes on a disk at this point. So doing something digitally was what we would want for a universal currency, but then the next problem for this is who would run it? Who would regulate it? If you have 193 sovereign nations uniting under one universal currency, which one is going to be printing it? Which one's going to be minting the coin? Which one's going to be regulating how it works? Well, if you're going to do a universal currency, you're going to have a lot of problems if you pick one country to run it. Someone's going to have a problem with somebody running it. So instead, you have a proposal that nobody controls it, but everybody manages it. And by manage it, I mean you manage your assets, like you can trade with it, you can buy with it, you can manage your own portfolio of cryptocurrencies, but no one can control it, meaning no one's regulating or dictating it. There's no middleman that's monitoring and moving everyone's money around. You're still in control of it and managing your own. There's no central agency that is in charge of the coin. And this is possible with blockchain technology. This is how Bitcoin works. There is no company that backs Bitcoin. Bitcoin isn't a company itself, it's just the name of the coin, and it's just code that's out there that people can run their cryptocurrency on. So there is no central agency. So they actually have the formal name for blockchain in this case then is decentralized consensus network. You're not going to hear that as much, obviously. Blockchain is a street term. Way more popular, way easy to read, and it makes all the headlines. So let's start with a working definition of blockchain, just to get something like, oh, okay, I get it, Luke, what is it? What we're going to be talking about, we're going to break this down as we go through some of these slides. A blockchain is a decentralized and distributed digital ledger that records transactions. So if you're familiar with ledgers, it's bookkeeping, it's all the transactions that are going on. A sends something to B, X sends something to Y, etc. And a very important property of the blockchain is that it cannot be altered retroactively without the collusion of the network or the subsequent alteration of all blocks. So this is very important in computer science. For all the computer science people in here, this is known as immutability. It cannot be changed. Once it is created, you cannot go back and undo something unless you just completely create a new blockchain. So with that being said, let's kind of try to explain decentralization and distribution in a network because up until now this is really a foreign concept of networking. What we're familiar with is centralized concepts. So you're really familiar with Twitter or Facebook or WhatsApp or any one of these centralized networks that you've been using all this time, Instagram, I mean anything you can think of, any phone app you've got, there's a company backing it. They manage your data, they get to see kind of into your privacy. I mean, I know this one's got big problems with privacy issues, especially in Germany nowadays, making headlines on that. But what's nice about centralized things is they will manage it for you. They offer you a service, they will take care of it for you. You just can't give up the right to your data to this company. They can sell it to the NSA, the FBI can watch it, and there's all kinds of controversy on stuff like that. In a decentralized interaction, we get rid of that middleman. That central agency doesn't exist anymore. So sending a tweet, instead of having something go to Twitter's server and then backing output to everybody else, you just kind of put it out there. It's just you just do it, and it doesn't go through somebody. It's just you making a tweet, or you sending a Facebook message, or you sending a WhatsApp directly to somebody else. And those people receive it directly. There's communication between all the nodes on the network. So I mean, just think of all the computers we have in this room, all the laptops, the phones in our pockets. We have more computing power in this room than what we had to get man on the moon 50, 60 years ago. So using all these tools and nodes to be able to connect, we can create a very, very intricate network. And if you zoom out this interaction, you end up having this decentralized network, more formally known as a peer-to-peer network. And this is where cryptocurrencies run on. This is the platform that they use. Instead of talking to a central server that runs everything, everyone just trades between each other. So I don't need to connect to somebody else. And it's really nice because that means there's no downtime. If somebody here were to be disconnected from the network still goes on. There's no problem with that. If Twitter were to go down, you wouldn't be able to tweet anymore. You would lose the ability to do that. So decentralization is great because the uptime on the network is far better than what it was when it's centralized. Distributed means that everybody's going to get a copy of the ledger. So again, that ledger is that list of transactions. So in Bitcoin's case, if Alice sends 10 Bitcoin, which by the way, BTC is the mnemonic for Bitcoin. BTC means Bitcoin. Alice sends 10 Bitcoin to Bob, Bob sends 0.57 Bitcoin to Alice, Alice sends 2.1 Bitcoin to Jennifer. These are just sample transactions that could happen. You would have a lot of these on one ledger, and everyone would see the exact same thing. Everyone gets a copy. So everyone would have, hopefully, the exact same copy of the ledger, and they're looking at the exact same thing. They're not looking to a central database that has it. Everyone gets it. Every node on the network gets the exact same copy. So if someone wanted to make a change, or say they made a transaction or a record, hey, I sent 0.34 Bitcoin over to Jennifer, then that would ripple or propagate through the network. Now that process of getting a record or a transaction that you've made out to everybody else is not instant. You might think it is, because computers are very fast, but it does take time for that transaction to get out to everybody, get collected by somebody, and actually put into the block. And that's going to be important as we go on, that this isn't an instant process. But that record will go to everybody else. Everyone will hear that, record it on their ledger, and you'll have the same copy that everyone's looking at. So, big thing on blockchain is, well, okay, what if I wanted to tamper with the ledger? What if somebody wanted to mess with the data that's on the blockchain? What if somebody, or like say Jennifer in our last example, what if instead of Alice saying I sent her 0.34 Bitcoin, what if Alice wanted to say, oh, well, I actually got 34 Bitcoin? What's really stopping us from doing that? And to answer that question, we really need to draw on an important tool in network and cryptography known as a secure hash algorithm. So a lot of people who have taken some cryptography classes know what a hash algorithm is. We're going to try to go over it really briefly, just try to give you a surface level understanding of what a hash function is, what it does, what it can do for you. You actually use these pretty much every day because this is how they store your passwords. So any centralized service like we were talking about, like Twitter or WhatsApp or Facebook, they don't actually see what your password is, and thankfully. I mean, you might not have ever thought of this if they saw it or not, but there's no IT professional on somewhere working at Facebook HQ that gets to see a list of everybody's passwords. They will never know what your password is, and for good reason, right? This is good security. What these hash algorithms do is they take your plain text password of any length. It can be of any length, whatever it is. It can be the size of the Declaration of Independence. It can be one letter. It will always output a fixed length hash. So despite these not kind of lining up well, they're all the exact same size, and they will always be a certain amount. I think this is 256-bit hash is being outputted right here. Another important property with hashes is that a very small change in the input will drastically change the output. In cryptography, this is known as diffusion. So in this example, I don't know why this is the de facto example English language sentence, but the quick brown fox jumps over a lazy dog, and in the second example, all we did was capitalize the A, and all of a sudden you have a very, very different looking hash that came out of it. So one thing about these hashes is if you change this a very, very little bit, it will drastically change the output. Another big thing about hashes is that they're irreversible. So no IT professional on the end of Facebook can look at the hash and try to do some decrypting to figure it out, because it's not an encryption-decryption scheme. Hashing algorithms are a little different in that they are one way, and it is impossible, nearly impossible, for you to go back. It's not actually mathematically proven to be impossible, but the chances of you being able to do that are astronomically low. So the hash algorithm that we're going to be concerned with for blockchain, especially Bitcoin uses this. It's called SHA-256. It stands for Secure Hash Algorithm. 256 indicating that this hash that's outputted is 256-bit. So I actually punched in capital H, hello, exclamation mark, and this is the hash of SHA-256, hash of hello. If you want to know how secure 256-bit security is, you're welcome to go look that up. It's basically 2 to the 256 different ways I could have an output here. If you're curious as to what that is, that's a 78-digit number. Trillions is a 13-digit number. 1 trillion is a 13-digit number. So add 65 more digits to a trillion, you have a really, really large number, and the chance of you guessing somebody's hash are very improbably low. So kind of understanding now what our hash algorithms are, we can take something of variable input, convert it into a completely different encoding of fixed output where we can't reverse it and there's no collisions, and a small change will drastically change the output. How can we use these on the transactions? How could we use these to protect people from the tampering like Jennifer was going to do from before? If a small change is going to drastically change the hash, if Jennifer wants to say, I didn't get 0.34 Bitcoin from Alice, I actually got 34, and she wants to move that decimal point over a little bit, well, moving it over by 1 or by 2 places is going to obviously drastically change the hash of that block. So this brings us to, actually, will bring us to blocks then. You don't want to hash every single transaction. That would be a lot of overhead. That's going to be a lot of computations. So what we're going to do instead is we're going to take groups of transactions that people are broadcasting on the network. Obviously, there's going to be more than just one person saying, hey, I traded some Bitcoin to Jennifer or whatever. There's going to be millions of transactions and broadcasts going on. So what's going to happen is we're going to collect them, group them into what we call a block. It's just a group of transactions. Also, if you read up on any of like stuff with Bitcoin or blockchain transactions, this is typical shorthand for transactions. And then you can hash the whole thing, because remember, a hash can take any amount of input. So it could be really large and I'd still get a hash of it. So this ends up being a digital signature or fingerprint of this block. So if I wanted to come in here and change something and fraudulently claim that this record wasn't what it was, I actually got $1 million out of this. This is going to be completely changed. So you can start to see how we can maintain the integrity of the network by checking these hashes. And if they change, then we know someone's tampered with something. So that's only one block. So obviously we're going to have more than that. So say like a block has a fixed size. I think in Bitcoin's case, block size is 2 megabytes. Ethereum does things a little bit differently. They limit their block size by the cost of each transaction via a gas limit. Either way, they're limited in size. You're not going to be able to store every transaction on one block. That would be ridiculous. So we have multiple blocks. So if we have all these blocks with all these lists of transactions, and each block that has a list of our transactions on it, we hash it to where it has its own little signature or fingerprint, what are we going to do with them? Do we just throw all these blocks into the ether space and just say these are the blocks? If you want to go check your transaction, go find your block's hash or address or whatever. Should we order them in any way? Is there anyone who wants to try to take a gander as if we should order the blocks or not? Anyone think yes? No? I'll try to lead you to the answer here. If Jennifer, and like I said, the propagation of a transaction takes time, right? It's not instant. So if Jennifer knows that fact, and most people on the network will, they'll know that it takes time for that record to get out there. She goes to Amazon, Amazon.com, let's say they're accepting, they have some products for Bitcoin. She wants to spend her 0.34 Bitcoin she got from Alice. She goes and buys something off Amazon with that, and before the transaction has gone to everybody in the network and been accepted, she goes to another vendor and says, I want to spend this 0.34 Bitcoin. This is a double spending problem, and she can double spend her coins. How could you prevent that if you want to order the blocks? Should you put them in order, like a chronological order? Would that prevent?
Yeah.
Yeah, it would. You would want to put these in an order, because if you do have a preservation of the history of the blockchain, then you wouldn't be able to double spend anymore. If I have something that says, yeah, Jennifer spent that 0.34 Bitcoin at Amazon, then there would be a rule that says, well, you can't spend it again. You literally just got rid of it. It says so in the history of our blockchain. You want to sequence these blocks in order. So the answer is change blocks. You start to kind of see why we get blockchain from this. We have our list of transactions. We want to hash them, and then we want to put them in a sequence such that the history of the transactions is preserved and such that people can't double spend their coins. So how would we change them? Do we just put a pointer on a block that just says this one's the next one? How would we chain these blocks together or link them together such that the history is preserved and people couldn't double spend? Does anyone want to take a guess? Try to. Any computer science students? I'll give you a hint. It uses hashes. Nobody. Okay, that's fine. You're going to take the hash of the parent block and you're going to put it in the new block. So the hash of this entire block will go in this block's header. The hash of this whole block will go in this block's header. And you kind of start to see this ripple effect. Remember, if you change something very small in a hash, it changes or very small in the input of a hash, it's going to drastically change the output of a hash. So if I change something in this block,
its hash is going to be very different. So if this hash is very different, then this block's hash is very different, and so on. It'll go down the chain. So if somebody were to come up here and rewrite some of the history of the blockchain, it's going to change this block's hash. So it would change the header of this block, which would change this block's hash, and you could see where you could start to find out where fraudulent things are happening on the network. This is a good way to thing to look into the block header. There's a lot of things actually going on in the block header, especially in Ethereum's case, which is very complicated blocks. But to boil it down, there's 6 main things here. Version and timestamp are pretty self-explanatory. Bitcoin developer, the core, Bitcoin core is what they call the core development team for Bitcoin. On their open source GitHub page, they have a bunch of different releases, a bunch of different standards, protocols that they push out to the network to update it. So this keeps the version number in check. Timestamp, obviously we want to keep things in sequence and chronological order. We want to chain those blocks. The previous block hash is very important. That's how that's chained, right? That's going to show us that things have been changed on the entire network. Difficulty target and nonce is something we're going to get to here in a second, but I want you to just put those in the back of your brain. That's going to be used for the proof of work algorithm that you might have saw before on the original picture. And then Merkle root, this is a more complicated tree data structure in computer science, but basically what it is it gives you just one little hash. It'll tell you whether or not a transaction is on a part of that block or not. It's a very efficient way to check for transactions. So one thing I want to mention in particular with the blockchain, so we think about like this one network, right? But I emphasize the plurality of blockchains because you can have for a moment more chains than the original one. So for example, let's say our blockchain network, we all have our shared distributed ledger that we're looking at. Technically, that ledger that we're all looking at really is the chain. It's the history of all the transactions, it's everything that's occurred. But if Jennifer wants to write down that she got 34 Bitcoin and not 0.34 Bitcoin, her ledger is now different than everybody else's. So she now is tasked with making sure that everybody else's copy that they have looks like hers. And she would need to make sure that people get that notion. So for a moment, there's like a second chain. There's another network. There's Jennifer's, where she's fraudulently claimed she has more money than she got, and then there's the original one that had the original transaction before she fraudulently claimed that. So you can actually have more than one chain, and this gets us to consensus protocols. So if I claim that I have more Bitcoin than I got, or Jennifer does that, say like Alice sends that 0.34 Bitcoin. Jennifer says, that's not what I got 34 instead. Now we have 2 different blockchains. For a moment we do. We have one network that's where everyone's ledger says, okay, Alice gave her 0.34. And then we have a separate network now that says, well, Jennifer got 34. So really the question is, who do we trust? Which one can we believe to be the real chain? Which one do we follow as a network, as a community? And the answer is to this thing called consensus protocols. And this is probably the biggest piece of blockchain technology, the biggest piece of consensus and security that helps make this thing run. And what's going on here for a consensus protocol? Well, first off, how can we reach consensus on this chain? How could we do that? How could we make sure, how could I prove that, and this is a pretty difficult question to ask, so I won't pass this one to the whole class, but you would need to have some kind of way to make everyone believe that this is the right network to follow. Now, Jennifer would try to have to get everyone and have consensus into saying, I have 34 Bitcoin. That kind of depends on how we're going to make sure that those fraudulent claims don't get through. And basically, it's a competition of guessing numbers. So if you're familiar with mining, this, which we're going to get into, this is basically that. Essentially, you are guessing a number, and this is going to help us preserve consensus in the network. And if you go research up like mining and stuff, they'll tell you it's a complicated computer algorithm. It's actually really not that complicated. It's pretty simple, and actually really it's kind of like this. So let's play real quick. So anyone want to give me a number between 1 and 10 trillion? Try to guess my number. 12? Nah. Can I get another one?
4 trillion.
Nope. Anybody? Yeah. Yeah, we could do this all day. Actually, we do this all year, and we probably never get it. Everyone in here combined. Yeah, sorry, it was just 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 9, 8. But anyways, This is essentially what is going on in Bitcoin mining. You are just guessing a number. Because, as we mentioned, those hashes of the blocks, there's a difficulty target, which is a part of the block header, which tells you that the network has a standard that says this block's hash has to look like this. And that is, it must contain a certain amount of leading zeros. So, if I have 256 bits, right, and I need a certain amount of them to lead with zeros, the more zeros I tell you it needs to lead with, the harder and harder it is to find that hash. If I tell you that the hash of a block that's going to go in the network needs to have 42 leading zeros, that is me basically telling you that you need to flip heads 42 times in a row until this block is valid and can be added to the chain. So that's essentially what's going on, 0, 0, 0, 0, 42 times. You need to have zeros 42 times. And that's chosen by the difficulty target. So if a small change in the hash input will have a drastic change in a hash's output, what miners are doing on the network is they're just throwing a bunch of numbers into the block until they get a hash that leads with the specified amount of zeros. So that's kind of shown here by this little GIF. You got 3 miners all trying to mine basically the same block that's pointing to the most recent parent block. And what's going on is here's them guessing the number. This is their mining rig, their computers, their GPUs, whatever they got all synced up. It's just sitting here cranking out numbers and calculating hashes until this guy gets the amount with leading zeros and he's okay to put his block in the network. So as a miner, when you do get this answer, you reach the solution, you get to write down, hey, I get 10, and this example, this guy says ledger dollars. You get to write a special little transaction at the top that says I got 0.3 Bitcoin out of that. That's the mining reward. You get paid to mine these blocks. The other 2 people who didn't get to mine this actually get nothing and it's over. They got to go find no new block to mine because you're supposed to have the hash of the most recent block. So once this guy has taken the parent hash of the most recent block, this is the new hash that needs to be prepended in the header of the next blocks. The other main big deal about this consensus algorithm that's called proof of work, because you are putting in a lot of computational work to find these hashes, is that the network follows the blockchain with the most computation, i.e. the longest. So this is really, really important in stopping people from fraudulent claims. Like I said, that Jennifer example, how do we know which network to trust? Okay, well, we're going to follow the one that's the longest. We're going to follow the blockchain that has the most blocks in it, that has the most computation behind it, because if Jennifer wants to alter one of the records and say, you know, I didn't get 0.34 Bitcoin, I actually got 34 Bitcoin, then what she now has to do, that block's hash has changed dramatically, so she has to calculate that block's hash by guessing that nonce over and over again, so redo the proof of work on it, and then do the proof of work algorithm on every block that came after that block, because it would have just chain reaction killed off all those blocks, so she has to recompute the hash for all those. And not only that, she would now have to compute faster than the rest of the network is computing the main chain, so that she is the longest chain that exists. She would have to now get her fraudulent record into the chain, hash it, hash every block after it, and then outpace everybody else in the network, which is near impossible for one person to do fraudulently. It would be called a 51% attack if you were able to pull it off, which we're going to talk about in a second. So if consensus is achieved by computing these hashes as fast as possible, and if you can compute it faster than other people, you can start to control the network. Would there be a concern with that? Do you think that there's a problem in having consensus via computational work? Does anyone think of any problem that could be with that? Any problems?
You have a group of people that join together to manipulate the network.
Yeah, you could have a mining pool. Actually, I think right now people it's said that you could spend, if you had $10 million of disposable income to spend, you could buy the supercomputing power to outperform the rest of the network and completely take over Bitcoin if you wanted to. So if you had $10 million, you could buy an ASIC, which is short for Application Specific Integrated Circuit, which is a computer chip specifically designed to mine Bitcoin. You just buy a bunch of these, rig them all up in sync, start mining Bitcoin, and mine faster than everybody else in the world, and everyone has to follow your chain because you have the longest, and that's how the protocol works. So that kind of does have some concerns. This stuff looks a little ugly. There's people that even have GPUs rigged up in sync in caves in other parts of the world, obviously, because it heats up too much. They want to keep it cool in a cave. This mining has kind of gotten out of control. So like we did, I guess the number between 1 and 10 trillion, their mining difficulty is insane right now. Actually, I think Bitcoin currently as it is today, your hash has to lead with 72 zeros, which is ridiculous. If you want to calculate the probability of you guessing that, it's basically flipping heads 72 times in a row. That's going to take you a long, long time to do. So people have, it's now very expensive to mine. If you got out your laptop and just started, and became a Bitcoin node and you wanted to mine Bitcoin, it would take you, I think it would take you like decades to mine a Bitcoin at this point. Your laptop or phone does not have the computing power to catch up with people and mine this. So what people do is they create mining pools. And what mining pools are is groups of people who put their computing power together. And they say, we're going to mine Bitcoin. When we mine a Bitcoin and we get a block reward, we're actually going to split it up amongst all of us. So mining community is growing smaller and more exclusive. It's more expensive to mine. You or I, laymen, won't even mine anymore. It now is in the hands of a bunch of mining pools who have all the power. And this kind of goes against decentralization. The whole point was that everyone kind of had equal power. We all got to communicate with each other and trade Bitcoin and spend Bitcoin on our own decentralized network. But now it's almost like if you can get 51% of the computational power of the network, you're really in control of the coin, and that's not really cool. So yeah, and this is a good definition of 51% attack. When a miner, or more likely a mining pool, controls 51% of the network's computational power. So if you were able to achieve this, you could really get away with double spending, you could make fraudulent claims, and everyone would have to follow your chain. So the alternative consensus protocol is proof of stake. I believe Nextcoin, which is one of the cryptocurrencies, uses this. Ethereum is going to roll out an update for proof of stake. It's called the Casper protocol, so they're also going to start doing this. This is in my opinion, much better way of achieving consensus than was proof of work. And how this works instead of computation, really what it does is it takes your stake in the network. So what you're going to do is, let's say you've got 10 Bitcoin, and that's about, say 10 Bitcoin is 0.00001% of all the Bitcoins that exist. You get to mine essentially 0.00001% of the blocks. So you lock up some of your cryptocurrency into, like, say, just like a little lockbox that's on the network. And there is going to be a random kind of finder that finds a node on the network and says, okay, it's your turn to mine a block. And your chances of getting selected are based on how much stake you put on there. So if you have a lot of Bitcoin, you will lock that up and you're probably going to be mining blocks more so than other people. Now the good thing about this is that, well, okay, one, there's no block reward. You actually just collect the transaction fees, so people are paying you. So that helps with scaling. Because before, if you're just creating new Bitcoin every time you're mining it, at some point or another it's going to run out. Because a currency needs to be finite. There can't be infinite amount of Bitcoin. There is a limited supply that's circulating, and if, at some point it would run out. So this helps with scaling problems. There's no harsh computation necessary, so it actually evens it out for most people. You don't have to have these huge $10 million supercomputer rigs that are mining for hashes to be able to get, override the consensus. The node actually just has to be online. So if someone is on a proof of stake protocol and their node gets selected to mine coins, what's going to happen is the network's going to point to them, say, here it's your turn to mine. That node will gather up some transactions, put it into a block, and publish it to the network, and that's all that really needs to be done. If fraudulent things were to happen, or if someone who is a stakeholder were to try to act maliciously on the network, what happens instead is, if that does get successful, then people just lose faith in the network. There's malicious activity going on. So what happens is people kind of pull out of the network, fork off of it before the malicious activity, say, forget that, we're going back over here, and your stake that you used to mine the coin is gone. So if you were a large stakeholder and you had like 30% of all Bitcoin, and you were mining a lot of blocks and you acted maliciously, you just lost all your Bitcoin. So it's kind of, there's some game theory in this that you would not be incentivized to act maliciously on a network at all, because you would lose your entire value, your economic value. And it's basically like mining, but if you were to act maliciously while mining, imagine your whole $10 million ASIC farm burning down in the process and all your Bitcoin. So the idea of somebody acting maliciously on a network like this is a lot lower than it was before. Makes various forms of 51% tax vastly more expensive. Like I mentioned, you could just have $10 million and achieve 51% in a proof of work concept. But in proof of stake, you would have to have 51% of the value of the entire network. So a Bitcoin's worth like 10 grand, and there's 20 million Bitcoin. You're going to need to have a lot of money to be able to attack the network. And even then, if you wanted to attack the network, you'd just lose all your money anyway. So there'd be really no point unless you just wanted to watch the world burn. So that's the end of really that's gone through the basics of blockchain, some of the consensus algorithms. I didn't want to lecture too long on it. I kind of actually wanted to do some discussion. If anyone has any questions, something that I didn't touch on, they're curious about, please ask. So, is there any questions? Anything or anybody? Yeah, what's up?
Did you talk about the split?
Which one? Like the BCH, BCC? Yeah. So okay, if you'll notice, if you ever go on like Coinbase or something, there's Bitcoin and then there's Bitcoin Cash. And that came from what they call a hard fork or a split that happened in I think August or September this last semester. And yeah, you can actually do this. You can take the technology that's on Bitcoin and you can just say, you know what, I don't like how things are run here. I don't like the rules of this network. I want to go to a network that does it like this. So there was some controversy between Bitcoin Core and some of the people on Bitcoin's network, like high stakeholders network, and then the miners. The miners wanted larger blocks. Yeah, they wanted higher block sizes because, let's see, the difficulty target increases, like we had this in the block header that shows you how hard it is to mine. Once more and more people get on the network, there's more computational power there, so it makes it easier to mine blocks, and the chain wants to mandate a specific time interval for when blocks are added. In Bitcoin's case, it's every 10 minutes. Every 10 minutes, a block gets added to the chain. And so what they were doing was they were making the difficulty target harder. So if there were 10 people on the network, they wouldn't make the difficulty that hard because they want people to be able to find blocks in 10 minutes. But now if there's like 1 million people on the network, they need to make it harder to mine so everyone's collective hash power doesn't mine blocks faster than they want them to. So they would make the difficulty target harder. What that does is it makes it harder for like you or I or smaller mining pools to be able to mine Bitcoin. Now we're just going to get absolutely squashed by these huge mega mining pools who can mine way faster than us and keep up with these new difficulty targets. So what they wanted instead was bigger blocks so that we would wait for more transactions instead of waiting for miners to mine them, and it was better for miners. So they wanted to leave and create their own thing, called it Bitcoin Cash. Yeah. Any other questions, anything you're curious about? Sure? Yeah, what's up too?
What's the implication of Bitcoin for people who have very little technical knowledge?
What's the implication of Bitcoin? Okay, I think there's more implication in what Bitcoin's running on than what Bitcoin is. So I think like in the early 90s when email came out, that's pretty cool. You can send some messages to and from people digitally. That wasn't a thing for a while, but now you can do it. But what was more impressive about email was that it was an internet. You could communicate between people instead of, hey, I want to send a message to you. I want to just broadcast a message to everybody on my webpage instead. And so that kind of came from email as the internet. I think for Bitcoin, the coin itself, I mean, my opinion on it's kind of low. It's kind of doing pretty bad right now. I think it's on the decline. I didn't say that, but I just think that. But the technology behind it is pretty impressive. Decentralized networks like this can do a lot. You can have decentralized voting. You can have decentralized healthcare. It gets rid of a lot of fees. It gets rid of a lot of middlemen in the way. I mean, nowadays you have to wait. Like if you want to do an ACH bank transfer, you got to go through so much bureaucracy to go through companies to get stuff. Decentralization makes things so much more efficient. Makes things so much more automated. You don't have people watching you all the time telling you what to do. So that implication of what Bitcoin's running on is probably the biggest thing for new people to the currency. What's up?
Could you talk a little bit about Bitcoin scaling?
Yeah, Bitcoin definitely has some scaling issues. That's kind of part of the split too, is they disagreed on where the direction the network is going. I think right now it takes forever to mine them. The fees are outrageous, and they don't have, so far as what I've read, they don't have any plan to go to a proof of stake approach. So I mean, they're continuously putting out more and more Bitcoin because people are mining it, and at some point you're going to run out. And it also takes up a lot of space, and it's not even really that too bad, but now I think the network's like 146 gigabytes worth of all the transactions, and that's just going to keep going. So if you wanted to be a node on the network, you would have to download all that. And the issue with Bitcoin scaling is they don't really have like a plan in place yet, is kind of what people are upset about. The developed Bitcoin core hasn't really put out a statement on what's going to happen in the future with it, so people have started to get a little shaky on its future.
Can you talk about the privacy of transactions, like if they're encrypted on
Yeah.
the ledger?
Yeah, so back on that slide when it said, hey, I'm Alice, and I sent 0.34 Bitcoin to Jennifer, that's not how you'd actually see it on the network. It would actually look like just a bunch of hexadecimal digits, something, more hexadecimal digits. Everything is actually going to get hashed. So you have a wallet address. I mean, that very first slide I had with my ETH wallet, if I sent like cryptocurrency to somebody, it would just say 0x and then all those digits of my wallet sent something to whoever. Those transactions aren't encrypted. You can go see those if you want. You can go to Blockchain Explorer, blockchain.io or whatever, and there are websites where you can just take a look at all the transactions that are going on. You're not going to know who's sending it to who. You're just going to see that some wallet sent this amount of Bitcoin or currency to this wallet. As far as your encryption stuff, there's private key, public key encryptions being used on this, which is a whole other realm of cryptography that, I mean, we don't really have to get into, but if you're familiar with it, I think, have you taken the security class, Duncan?
No, but I know what that is.
Yeah. So they use PGP on blockchain, which is short for pretty good privacy, which is just a private key public key encryption algorithm, which the short for it is you have a private key that no one gets to see. It's kind of like what Tu was talking about when he was handing out the Bitcoin reward. No one should see the private key, but you also have a public key that everybody can see. You can encrypt things with the public key and send it to the user, and they can decrypt it with their private key. Or the user can encrypt with their private key, send it to somebody else, and they can decrypt it with your public key. And it kind of verifies authenticity that way and keeps things encrypted so you can't read it. Yeah.
I was wondering, could you touch on your smart contracts and secure ledgers?
Smart contracts is something that is big on the Ethereum platform. So there's blockchain, and they talk about blockchain 2.0. And basically blockchain 2.0 is this whole idea of smart contracts. So some people have asked me today what the difference between Bitcoin and Ethereum is. Bitcoin is an application, Ethereum is an app store. So you can have tons of different decentralized applications running on the Ethereum platform. Ethereum actually isn't a cryptocurrency. Ether is the cryptocurrency that is a part of Ethereum, and it's what fuels its network. Ethereum is actually just a different internet for people to build on. They've already started building new applications for it, and you can build these applications via smart contracts. And what a smart contract is it's a fancy word for just some code. It's someone who wrote a program in, Solidity? Solidity is Ethereum's new programming language that you can write smart contracts in. So you just write a program that says, hey, when someone interacts with this wallet or this address, run this code. And you can start writing a ton of applications to run on the Ethereum platform, and these smart contracts act as their own nodes on a network. So I think they have a bunch of different, I think on Ethereum alone, you'll hear like cryptocurrencies versus crypto tokens. And a token is a cryptocurrency that is running on another cryptocurrency's platform. So Ethereum has something called ERC20 tokens, and there's like 50 of them. Among the 1,000 cryptocurrencies that exist, like a bunch more are running on the Ethereum platform, and that's done by people writing the code of the smart contracts on the network. Yeah. It's very innovative stuff. Yeah.
So what determines the value of cryptocurrency, and what is its basis of value?
Yeah, okay, so I guess I didn't really touch on that. The currency is the ledger. So you physically having a Bitcoin isn't a thing. What really it says is there's a ledger that says that you have it, and the value is determined
by the consensus that we agree that it has value in the first place, but the specific like US dollar value, that starts to get into economic stuff that I'm not as familiar with. But basically, you have buy and sell orders. People are trying to buy into the network. People are trying to sell their Bitcoin, and at the same time, so you have these buy and sell walls, and it's basically where the buy and sell walls meet. So if everybody just stopped buying, all of a sudden, and nobody wants Bitcoin, the sellers are going to have to drop their price until they meet the lowest buyer, and once it hits that point, that's the new value of Bitcoin. And this thing is obviously, if you stayed up to date with it, it's super volatile. Those drops can happen out of nowhere. The cryptocurrency community likes to call people who have a lot of stake in the network whales, because if you have a ton of Bitcoin or a ton of Ethereum and you just sell all of it, you've essentially just fulfilled every buy order. If you have enough of it, you can theoretically fulfill every single buy order all the way until there's absolutely none. So if you have a ton of one cryptocurrency, it's actually very, very ignorant to sell all of it at once, because you're not going to get the value of it as it is right now. You're going to be plummeting the value as you're selling your coin by meeting those buy and sell walls meets. But that's basically what determines its worth. Yeah.
What are some of the business applications of the blockchain technology?
Yeah, they have a bunch going on. I think they even have like IBM's like a commercial for blockchain cloud computing. You can have those business applications can go into voting. So I know, like voting with the past United States election was all whatever, Russia tampered with, blah blah blah, and everything. You could have a decentralized blockchain platform run voting, where instead of us using cryptocurrencies as the currency, you just trade votes and send votes to a wallet, and these same exact cryptographic and security principles would apply to that chain, prevent people from double voting or instead of double spending, and prevent people from altering the votes, and you'd be able to prove that you voted. So there's a lot of ways that you can do that. You could have decentralized healthcare. I haven't looked into that as much, but I heard that I've read some ideas on it. People have already started making decentralized games. So there's a ton of different things you can write. If you can think about it and code it as software, you can get it on the Ethereum platform and run like a blockchain application for it. So it's got tons of implications. Any other questions? What's up, too?
I guess this will be the final one.
All right.
A lot of people know about Bitcoin because of its rising price.
Uh-huh.
So about the reason why.
Talk about the reasons in the rising price.
Yeah.
So this goes back more into economic stuff, but it gains a lot of popularity. Again, people are going to be buying into it a lot. It's just going to keep rising and rising. It got really popular. It hits some news. It makes headlines. People want in. People hear it makes a lot of money. And for a while, people are like, "Yeah, this isn't anything." And what it has done before is it's peaked and fallen back down. And back when it peaked originally, people were like, "Oh, I wish I would have bought Bitcoin." But that second wave hits, then people who are saying, "Oh, I wish I would have bought into Bitcoin," can remember that and buy back into Bitcoin. And you just keep buying and buying and buying and buying until the price goes way out of control. Obviously, there's bubbles associated with that. If it gets really high to a point where people are going to start selling it, then it's going to crash. And we've seen that in the last month. I think like when winter break was just about ending, Bitcoin was like $18,000, $19,000 a coin. It's like $9,000 right now. I haven't checked it today, but it's been cut pretty sufficiently.
Which coins do you predict will survive in the long term? Ether is probably one of them, right?
Ether's a big one, I think. I got two that I'm a big fan of. So Ethereum, I like Ethereum because it's not really just a cryptocurrency. Again, it's a platform for basically, you can think of it as like quote unquote a new internet, all right? Ethereum is trying to get blockchain out there to as many people as possible and people developing on it. There's new jobs opening up for software engineers on blockchain. So I think the currency Ether will do really, really well. I don't know, I think it'll do really well for itself. I don't know if it'll spike to Bitcoin levels like it did. Bitcoin had, I think, a circulating supply of like 20 million. There's
21.
21 million circulating supply of Bitcoin. Ethereum has like 95 million. So for Ethereum to rise to the price of Bitcoin, its market cap would be astronomical, which isn't out of the question. Obviously, there's some markets that do exist with crazy market caps like that, but I think it'll do well just because Vitalik, the owner of Ethereum, or the creator of Ethereum, is running it. They have an awesome team,
very good at developing and have a good future for their program. They're even coming out with proof of stake on that network, so they've solved some of their scaling problems. They're up to date. The other coin that I like is called 0x. So in blockchain, right, our big buzzword is decentralized. We don't want to have to deal with a middleman. Well, a lot of people, if you walked away from this talk and said, okay, you know what, I'm gonna buy like $10 worth of something. I don't know if it'll be Litecoin, it'll be Ethereum or Bitcoin. You're gonna go get on an exchange, you're gonna register yourself, and you're gonna start trading those assets and buying them. But what you've just done really is now you're not really decentralized as much as you were, because now you're working through Coinbase, or you're working through Bitfinex, or you're working through Poloniex, or any one of the exchanges out there you now have an account on, and that's a centralized agency. You're working through an exchange to manage your cryptocurrency assets. So 0x is a token, its project is to get rid of that. Hence 0x, zero exchange. It is a decentralized exchange, which for short they just say DEX. And it's the idea that if I wanted to trade or buy Bitcoin or Ethereum or something from somebody, we could just do it online via the 0x protocol instead of going through an exchange like Coinbase, who has outrageous fees. Like if I wanted to sell some of my assets on Coinbase, I think they take like 4% on some of the sells. Which, I mean, if your Bitcoin or your Ethereum turns out to be worth like $100,000, then Coinbase will take $4 grand when you try to sell it, which is ridiculous. Those fees are insane. So 0x is a really good way to get around that, and it's, I think, really the core heart of decentralization. So, yeah.
All right, thank you.
Yeah, absolutely.